Hello everybody, welcome to this tutorial. In last week we give an introduction about autonomous system, the definition, the design, and the main components of the autonomous systems. And then also we have a look into the technologies that use in designing and implementing the autonomous system. So from today we will start with a new topics. That topics actually it's focusing on analyzing the autonomous systems. As I explained earlier, we will use a new approach for analyzing the autonomous system, which is COMET methods. So today we'll talk about these methods. So we'll start introduction about these methods, and then what's these methods and the step of these methods. And this is the first step or the first phase of these methods, which is the requirement modeling. In requirement modeling, we have many steps, or we can say we have many multi sub-step. It's the first one, it's goal specification, scenario also specification, and use case modeling. So this is the first one, which is requirement modeling. So we will see these two, and the next week we will see how we can use the use case modeling as a part of requirement modeling. So guys, as you know, this is the software development life cycle. Or we can see is the common step in software in most of the existing software development life cycle, even is waterflow or agile or any methods or any model, they use this step. So here we have requirement modeling or elicitation. So and then analysis, system design, details, the design, implementation, and they end with testing. So this is the common step. So we will not go far from this step. We are working on this step also. But as I say, it's this step, it's focusing on, we can say it's for any system, can be used for any system. But most of the existing model that use this step doesn't focus on what we can say is the real-time system. The real-time system, which is also the autonomous system. So here we can say that we have many models, or here before that, we have many models that can be used for developing the software, but most of them actually we can say is used for sequential or sequence system. What the sequence system? The systems that's the task it's implemented step or in order, in sequence, one after one. So this is most of the existing model. So here we have, we cannot say our own model, but we have a new methods that's suitable for our subject. This methods actually is used for concurrent system, used for distributed system, used for real-time system. All is actually the same concept. This system is, in general, we can say it's autonomous system. Autonomous system, which is not only based on the sequence of the system or the sequence of the instruction or sequence of the task, but also based on the current input, based on the current times. So that's why we have to find another way or another methods to study this system. So here, this is just recap about the UML diagram. We have many UML diagram, and each one is suitable for one for specific systems. So some of them actually maybe we can later we will see is more details when we will use each one. Okay, so we have many, okay, based on the models, some of them, some models they use only, for example, for study the structure of the system, they use, for example, the class diagram. Some of them they use class diagram with, for example, the interaction or integrated diagram. So based on the model. So that's why we say what is the suitable model, or what the suitable behave, or what is the suitable model or methods. It's can be used for our subject. We have many methods. We have, I did not list it here, actually I find, but I did not list it. There is many methods that can be used, many methods, many approach. So what is the best one that can be used in our methods? We find, or we select these methods, which is COMET methods. So what is the COMET methods? This is UML based. It's a UML based model or methods used to study, analyze, and design the concurrent system. Okay, this is in general. Also, it's object oriented. We have many object oriented, but some of them, as the first step here, some of them it's used even as even it's used object oriented analysis, but not designed for distributed and concurrent system. So we find another method which is also object oriented, which is the common model that used nowadays, but also supporting this kind of, here I listed here also in the second slide, is the distributed system and real-time system. So example of the real-time system, for example, okay, most of system now actually is, we can say, is real-time, even is a normal system, but also since it's used online, for example, so this is also we can consider it as a real-time system. Elevators, robots, many system is now it's real-time system, and the system, this system not only based on the input, or we based on the task or the ordering task, but also based on the input and the situation, and the current input and the current situation. So that's why we say here we come with this method. This method is actually it's UML based. That means we will use the notation of UML, we will use the diagram of UML, but we will add something based on this method. They add the input actually is as a devices, not the input as, for example, only letters, only text. No, there is text you can input, you can use the input, for example, from the keyboard, but also can receive the input from the sensors. So it's UML based diagrams. That means we will use the UML diagrams. Also, it's object-oriented diagrams, object-oriented based. That means also we will use the concept of the object-oriented. So every entity, every devices, every surface, every algorithms will be represented in this system as object, or in this model, because here we're just modeling the systems. So the COMET method, it's a concurrent object modeling and architecture design methods for developing concurrent application in practicals, distributed and real-time applications. So I think the definition is clear because we already gave introduction about it. So it's used for concurrent system. This concurrent system such as distributed system and real-time system. Also, these methods, it's, as I explained in the previous slides, it's UML based. That means we will use the UML diagrams to support this design. So the type of the design that is supporting by these methods is the concurrent system, distributed system, and real-time system. So the name is coming from concurrent object modeling architecture and design methods. This is, they do it like this, but it's okay. But the name is COMET. There is many application in these methods. Also, there is some book. I will provide you the book. I think it's already in Kalam. Also, this method, you will see the diagram. The next slide, there is the step of these methods is iterative method. That means you will design, for example, the first step, the second step, and then you come back to design the first, and then until you satisfy or until the customer satisfy this design. So in software, also in these methods, we, as I told you, we focus on the, or we, it's UML based diagram, UML based methods. So we use UML diagrams and notations to design the model based using these methods. So we will see the function, we will list the function, and they will use the use cases for each function of this system as well. We will use the class diagrams, we will use the communication diagrams, sequence diagrams, state chart diagrams. But as we said, there is some slightly different between the one you learn and now. It's only small things. That's why when you select your project, don't just repeat what you studied before in the software engineering. Okay, don't repeat the same, because this is should be same, should be different, should not be same, it's different. So if you just select the same project and then you say, okay, this is autonomous, or you apply these methods, will not be correct. So guys, this is the step of these methods. This is the step of these methods. So we have, just we can say it's different step. The first one is maybe now, because in the end I provide you the, we can say, is the full description for each phase, this for each one. But maybe if we go now, maybe no need later to mention it again. So in the first step, guys, maybe you know that any model, any software development lifecycle model, they use to collect and elicit the requirement. So this is also, we have this step. In this step, actually, we will collect, you have to collect the requirements, the function requirements, non-function requirements, so all these requirements. And before that, actually, we have three. In the first one, we have three things. The first one is the goal of the system. You start to find or identify the goal of the system. And the second one is the scenario, because actually it's in these topics or in this course as autonomous system or real-time system, it's better to find out what's the scenario that's we can say is expected to present in this system. So first, identify all the scenario. After you identify the goal, after that you study the use cases. So this is maybe the three main sub step in the first step. The second one, we have the analysis modeling. After requirement modeling, we have the analysis modeling. In the analysis modeling, actually, we will study two parts. We can say is the first one is the static model. Inside this one, in the analysis modeling, we have two also two sub-step. One is study the static model of the system. Static model, that means we will study the entities of the system as, okay, similar to what we can say is the tables of the system. So we'll study the static model. And the second one is the dynamic model. There is a details here. Dynamic model, what we have to do. And the third one is, the third one is the design. Actually, we will stop here. the design. The design here we will study the architecture of the system. We have subsystem, or we have sub-step here. Some architecture model we have to develop it, and then here we can say this is actually it's similar now. Yeah, here in the design or in developing in these two steps. Now after design, our works actually until the design. So after designing, now you should to produce your products. So we will not go for this, and then testing as well this. So here, as a part of this 3-step, because our subject is design autonomous system, architecture design. So in the design also, we have also to verify our design. Okay, here we will develop the architecture model as well. We will develop, we can say it's verification model. So this is the main step. Here also is more details, the same that what I told you right now. We have the requirement modeling. In this requirement modeling, after identify the goal and then the function and the non-function requirements as well the scenario, come with use cases. You have to develop the use cases model, and then we come to the second step, which is analysis modeling. Here we focus about 2 parts, which is the first one is the static model. The system, there is some parts in the system will not be changed during the runtime. So this is the static model. So we have another aspect, which is the part or the things that will be dynamically changed. So we can see the behavior, the relation, and so here anything is related to static, the first one, and this is the dynamic, which is we can see the communication between the entities. Here you can say, okay, after we develop the static model, which is the entities and the relation between them. So we have to see now the communication. How's the communication between these entities? So the communication will be in the second part, which is in the dynamic part. Then we go to design modeling. So this is the 3 steps that we have to focus on. Design model, as I told you, the design will go toward the architecture, and then how we identify the subsystem of the system, and then how this subsystem is integrated and communicated with each other as a subsystem. In the design, we'll focus on the system, but as a subsystem. Why we select these methods? To be used in this course? Okay, as I explained before, there is many methods can be used for study and analyze and modeling the system, but most of them actually even it's use object-oriented, methods, but that system or this that models or methods is focus only on or we can say support only the sequential system. That means all the tasks it's run in the sequence. Okay, all the tasks run in the sequence. So maybe you can, if we say some example, for example, maybe okay, during the registration we can say, okay, you start, okay, just key in your data and then register, and that register go to payment, and some step or task it's run in sequence. Okay, so this one, it's most of the model or most of the methods is supporting this type of systems. So there is also some object-oriented methods supporting this. So it's okay. So in our system in our systems that we have to study, we can say it's not sequential. not sequential systems. Our system is concurrent system. Our system is real-time system. You see, this is also real-time system, but why we say real-time system? Because you will send the data, for example, to the server, and they receive the data. You send, there is some kind of real-time system. But here, if we are talking, for example, about the elevators, this is real-time system. Also should be is concurrent system because, for example, okay, the task now you have to go, I mean, from the level 1 or the ground floor to level 5. So suddenly, okay, the user, once it's starting move, the elevators, the users click something. Click, for example, stop, or he change mind and then not 5, he want level 4. So in that time, we see here not only, okay, we have this task, which is go to level 5. Not only this task should be completed, I mean, should be done only. No, we have also waiting any input from the user. We should wait from any input from the user, then we can change also the behavior of the system and then do the other task in the same time. That's why we say here this sequential actually is task after task, so all the task is run in sequence. But here concurrent task should be, okay, maybe in the same times run two tasks. So we have to find or study another method, which is the COMET methods.